In this video, we're going to talk about a very important skill to have when you're performing integrations. So let's look at an example here to demonstrate this. Let's say you have a function f at x is equal to the square root of 3x minus 4. We know we can rewrite this as just 3x minus 4, and then we will write it to the power of 1 over 2. And now we're asked to find the integral of that. So the integral of f at x dx. Well, from intuition, one might be tempted to do this. So you'll do just the simple power rule, okay, with this being 1 over 2. So you would take the integral, so you'd raise the 2 to a 1 here, and then divide that by 1 over 2 plus 1, bam, that gives you this function here. But the problem is this does not account for what's inside the bracket here. And in fact, this answer is actually incorrect. Okay, this is wrong. Okay, this is the wrong answer. Okay. Simply doing a reverse power rule doesn't cut it for this kind of example because it does not account for what is in here. So how do we evaluate this integral then? Well, one thing we want to do is we want to put this in terms of a placeholder. Okay, so what do I mean by a placeholder? So let's say, we'll say 3x minus 4 is equal to some placeholder. I'll just make it a box. Okay, we'll call it box. Okay. What that means is the derivative of that placeholder, okay, the derivative of the box with respect to x is equal to, okay, so it'll be 3, and then this 4 just reduces to 0. Okay, so we have that. This is very important to have. So now let's continue on. So what we can do now is we can rewrite this integral as f at x, okay, so f at x dx is going to equal this right here. So this placeholder to the power of 1 over 2 dx, right? Because this box here is equal to 3x minus 4, which is that right there. Now, the next problem is, here, let me just write this a little bit bigger. I'll write this a little bit bigger here. Okay, so 1 over 2 dx. Okay, so now the next problem is, this is in the form dx. Okay, what we want is this, we want to be differentiating with respect to the placeholder and not respect to x. So what we can do is we can take this, okay, and multiply it by d box by dx. And what you'll see is this. You can sort of visualize it as the dx is canceling out. Okay, so you can visualize it as these dx is canceling out, right? And so that'll give you d. You'll have this integral with respect to this box here. So what would that look like? Well, that would look like this. Okay, so this box here is equal to 3x minus 4 to the power of 1 over 2 times dx. Okay, dx. Now what is this box here? Okay, d box by dx. Well, it's equal to 3. So times 3. Which is good because now it is in a form where we're not really considering these dx's here, right? We're differentiating with respect to the box. However, there is one small problem, and that is this new expression here does not equal this expression here. Okay, it does not equal this expression because of this pesky 3. So what can we do to have the best of both worlds so that we have it A still equaling this, but also B still be in a form where it is where it's in this form here. Okay, so where it's in a D box form. We simply just multiply this by 1 over 3, which you can visualize it as these 3 canceling out. And there you have it. Okay, so we can integrate from this point on, because what we can do now is we can just take this 1 over 3 out of the integrand, 1 over 3, out of the integrand times 3x minus 4 to the power of 1 over 2 times 3 dx. Okay, and now what is amazing about this is that this entire expression still equals this expression here. Okay, this expression still equals this expression. And on top of that, the integrand, okay, this integrand is now in a form where we can integrate with respect to this box here and not worry about the x. Okay, that's ideally what we are looking for in this case here, which is good. So now we can just go ahead and integrate this. So when we do that, we get this. We get 1 over 3, okay, times, then we'll just do the reverse power rule here, times, so we go 3 to the x minus 4 to the power of 3 over 2 divided by 3 over 2, which is just the same thing as times, or I'll just divide by 3 over 2. Okay, plus c. Now we're going to scroll down a little bit here, and then this would be the same as 1 over 3 times 2 times 3 to the, create a little bit more space here, 2 times 3x minus 4 to the power of 3 over 2 divided by 3, and then plus c. And of course that'll give us 2 over 9 times 3x minus 4 to the power of 3 over 2. And this is the correct answer. Okay, this is the correct answer, not this. Okay, this is wrong, this is correct. Okay, so it's just important that you know how to use that substitution. Okay, use that placeholder to help you account for what is inside the bracket. So let's do another example to solidify this a little bit. So I'll scroll down even more. We'll do another example. Let's say we have a function called h at x. Okay, so I'll just create more space here. We have a function called h at x. H at x, and h at x is equal to x times 3x squared minus 2 to the power of 3 over 2. And you're asked to find the integral of h at x dx. Okay. So how would we do that? So again, we're going to be using the exact same steps as in before. So we would write, first of all, what we're going to do is we're going to set our placeholders. So what we're going to do is, okay, we're going to take this, okay, the inside of this bracket here, and we're going to let, this box, okay, we're going to let our placeholder equal this, whatever is inside that bracket. So 3x squared minus 2, which means that the derivative of that placeholder with respect to x is equal to, using our power rule, 6x, and then the 2 just reduces to 0. Okay, so that's the first step. We got our placeholder, and we have our derivative with respect to the placeholder. Now, the next thing we're going to do is we're going to substitute this placeholder into our integrand. Okay, so remember that h at x is equal to 3 of x squared minus 2 and to the power of 3 over 2. So that means when we substitute that placeholder in, we get x times this box to the power of 3 over 2, there should be a dx here, dx. But as you can see, this isn't in a d box form, right? We want this to be in a we want to be differentiating with respect to this this box here. So what we can do then is multiply that, okay, by the derivative of this box with respect to x, and then as you can see, these x's would cancel out, and so now we would be differentiating with respect to the placeholder and not x. So then we would write it as this. So we write x times, we would substitute our box back in, 3x squared minus 2 times dx times this, which is 6x. Okay, but no, as you can see here, we already have an x, which is good. Okay, the only thing we need to do to make this equal to 6x is add a 6. All right, so we're going to multiply this by 6. Right. I don't know if you see where that comes from. So again, we want this to be in the form, we want it to be multiplying by 6x. Now as you can see outside this box, we already have an x here. So what we're going to do is the only thing we need to make this 6x is just multiply by 6, and there we have it. But of course, this expression does not equal this expression here. So what we're going to do is multiply by 1 over 6. 1 over 6. And so another way to look at it is this. So if we simplified it, we would have 3x squared minus 2 times 6x. Okay, that's what we wanted, right? We wanted this d box by dx, 6x, so we got it now finally, times 1 over 6. But as you can see here, this integrand right here, what we want to do is we want to make sure it's in this form here. We want the integrand to be in this form, right? So we will just simply take out this 1 over 6 and bring it outside the integrand. So we'd get 1 over 6, and sorry, this should say to the power of 3 over 2, to the power of 3 over 2. 1 over 6 times the integral of 3x squared minus 2 to the power of 3 over 2 times 6x. Okay, this should say dx. Okay, so now that that's all in there, it is now in a form where we can actually integrate this integrand. Okay, because now there is it's in this form here. Okay, it's in this form. So we can integrate the integrand. So let's go ahead and do that. So 1 over 6 times, okay, 1 over 6 times 3x squared minus 2, and then 3 over 2 plus 1 is 5 over 2. 5 over 2 divided by 5 over 2. And then when we simplify that, that gives us 1 over 6 times 2 over 5 times 3x squared minus 2 to the power of 5 over 2, which will give us 2 over 30 times 3x squared minus 2, and there should be a plus c here too, plus c to to the power of 5 over 2 plus c, and the 2 over 30 can simplify to 1 over 15. So get 3x squared minus 2 to the power of 5 over 2 divided by 15 plus c, and that is your answer.